My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 386. In this lecture, we will try to understand code samples of support vector machines. We will look at some code for support vector machines on scikit-learn. If you notice, there is huge documentation for support vector machine. If you go to the page scikit-learn, just see the page. This is the page. What is this particular page? scikit-learn.org stable modules svm.html. We will get huge documentation, everything about svm. Just see, for example, it talks about what happens if you apply linear svm. It explains about linear svm, or I can say RBF kernel svm or polynomial svm. You can see documentation for different types of svms, isn't it? For example, here he is explaining for which data set? For iris data set. Iris dataset. You can see the classification, regression, density estimation, complexity. Just go through, just browse this particular documentation. There is a lot of nice documentation and lot of sample code in this single page. And thankfully, what scikit-learn does is scikit-learn implements. It implements what it can implement: support vector classification. Support vector, it implements support vector classification, new SVC, new support vector classification, and also it implements support vector regression. Support vector regression. We will try to understand all these, all three of them. So the support vector classification, obviously it implements kernel variant, isn't it? What is the meaning? Support vector classification, what will it do? It implements kernel variant. We will try to understand. Let's look at each of these codes. Suppose in iris dataset, what is iris dataset? We already discussed about iris dataset long back, isn't it? There are three types of flowers, isn't it? Yes, three types of flowers, isn't it? So if you look at sepal width and sepal length, just see, on y-axis sepal width, on x-axis sepal length. They have two features. And if you do support vector classification, this is support vector classification, because you have three classes in multi-class setting. SVM does it using one versus rest. Yes, in multi-class setting, SVM does it using one versus rest model. Now just see, now when you do that, look at the separating hyperplanes between three classes. You get straight lines here. Just see, this is straight line, this is straight line, this is straight line. You are getting straight lines, isn't it? You get straight lines separating them. This is SVC with linear kernel. Similarly, this is SVC with linear kernel, isn't it? Similarly, what happens is sklearn also has a function called linear SVC. This is linear SVC, isn't it? Which behaves exactly very similar to SVC with linear kernel. It's a linear SVC behavior is similar to SVC with linear kernel. As soon as we go to the, just see here, what are the separating planes? These are the separating planes, isn't it? As we go to the polynomial kernel, where is your polynomial kernel? Yes, this is polynomial SVC with polynomial kernel degree 3. What are the separating? This one is separating, isn't it? What does it mean? Polynomial kernel with degree 3. We can see the quadratic like surfaces which are separating these three classes. When we do with RBF kernel, just see, RBF kernel, we can get any arbitrary shape. When you do with RBF kernel, what happens is you are getting this region. This is one region. What about this region represents one class, and other one is, which is other one? This is one more region, and this is another region. There are three different regions, isn't it? Here you are doing with same iris data set only with two features, sepal width and sepal length. These types of visualizations are very, very useful to learn the decision surface. Now let's go to the documentation of SVC. Just we'll try to understand what is SVC. This is documentation of SVC. What it says, sklearn.svm.svc. Now let's go to the documentation of SVC. Here you have sklearn.svm.svc. So if you look at this, you will see what is your first hyperparameter. This C is first hyperparameter, isn't it? Kernel equal to RBF. We already discussed about RBF. Linear kernel basically means Xi transpose Xj. This is linear kernel, or polynomial kernel, RBF kernel, sigmoid, or you can create your own pre-computed kernel. Given every pair of points Xi and Xj, given every pair of points Xi and Xj, if you have the kernel K of Xi, comma Xj, you can give the pre-computed kernel. You can give pre-computed kernel itself, or you can define your own kernel function and give it here. That's the function of this. If you are domain expert who knows how to measure similarity between the points, you can design your own kernels, isn't it? It's possible. Now that's the second parameter. First parameter is C, which tells us about trade-off between bias and variance. The second parameter tells about RBF. If I have kernel which is polynomial, then only the degree thing is useful. Here we are saying degree. When it is applicable, if your kernel is polynomial kernel, then only this degree thing is useful. Now gamma here, what is this gamma? Gamma means what? Gamma here it says, if I say gamma equal to auto, if I say gamma equal to auto, what does it mean? If I give it, remember RBF, in RBF kernel we have sigma. In the RBF kernel definition we have sigma. Then what is this gamma? Gamma equal to 1 by sigma. This is a relationship between gamma and sigma. Instead of calling as sigma, in scikit-learn it is often referred to as gamma. Gamma equal to auto. It will try to fit, isn't it? If I say instead of scale, if I say auto, it will try to figure out right gamma function for the data set. Coefficient equal 0, shrinkage equal true. These are the parameters which are best left to the default values. These are the parameters which are best left to default values. They are useful to work your algorithm work better. Probability equal to false. Yes, I have probability equal to false because support vector classifier does not give you clean way to give your probabilistic interpretation of SVMs. Means if you make it true, there is some hack through which you can get the probabilistic interpretation of support vector missions, but internally, natively, support vector missions do not give a probabilistic interpretation. What is tolerance here? Basically means, remember, what is tolerance? This is, you have TOL, tolerance equal to 0.001. What does it mean? We saw similar parameter of tolerance even in the case of logistic regression. So tolerance basically says, when I am going from ith iteration to I plus 1th iteration, let's say I have Wi. Let me assume I have Wi and Wi plus 1. Wi and Wi plus 1. If the difference between them, Wi and Wi plus 1, if it is less than or equal to tolerance, isn't it? Less than or equal to the tolerance, then terminate the iteration. What is your conclusion? Terminate the iteration. Do not go any further, isn't it? It is termination criteria. I can say, what is this? This is termination criteria. Yes, what it says, again, just check other parameters. If you are trying to do multi-class problem, what is this OVR? OVR means what? 1 versus rest. rest. What is the use of this? This is for multi-class problem. Class weight. What is this? Class weight. Just see here. You have class weight. What does it mean? Here basically means, suppose if you have imbalanced data and you want to give more weight to one point, suppose if you want to do upsampling of one class, then you can give class weight. So the maximum number of iterations, if you set to -1, what is this max underscore ITR? If you set it to -1, it will keep iterating till the tolerance is reached. That's how support vector classifier works. Code is very, very straightforward. Suppose if I have my x, let me say this is my x. I have my x and y. I basically import my support vector classifier and say CLF equal to, what is my CLF here? CLF equal to svm.svc. Now I will fit CLF dot fit as usual. Fit means, isn't it, which we discussed. It is exactly like every other classifier. Fit function is common for all classifiers, and of course I have all the parameters of SVC. In scikit-learn, the beautiful thing is, if you wanted to go from one classifier to other classifier, just what you have to do? Just you have to change this single line, CLF equal to just other classifier, whichever classifier you want, you can do it. That's it. Everything else working, isn't it? Everything else work. Your total data set, let me say your total data set is D. I can divide this into D train, and I can say this is D train and D test, isn't it? Whole idea of cross validation, your whole idea of grid search, all of them are the same. Only thing you have to do is understand the classifier function. Here the classifier function is very, very simple. That is support vector classification, SVC. Just anyway, we will try to understand. I will continue my discussion on this particular sample course of support vector mission in my next lecture also. Just go through the simple code, and if you have any difficulty, please keep a comment. Thank you very much.